Saturn is adorned with the most spectacular and complex ring system known to exist in our entire solar system. To the naked eye, the night sky is a tapestry of solitary points of light, but through a telescope, this golden giant reveals its glorious halo. These rings are not a solid disk, but rather a vast, shimmering collection of countless ice particles, ranging in size from tiny grains of dust to massive boulders as large as mountains. They orbit in a perfect, flat plane, guided by the silent laws of gravity that keep them organized in their lane. It is believed that these rings may be the remnants of an ancient moon that drifted too close, or perhaps comets that were captured by the planet's immense pull. As they circle the planet, they reflect the distant sunlight with a brilliant intensity, creating a celestial jewel that has captivated observers for centuries. They are a testament to the elegance of orbital mechanics, a silent, glittering dance of ice that continues endlessly in the quiet dark, wrapping the planet in a permanent embrace of light and frozen history. Despite its immense size and mass, Saturn is the only planet in our solar system that is less dense than water. Imagine a bathtub vast enough to hold a planet, stretching across the cosmos with waters calm and deep. If you were to gently place Saturn into this imaginary ocean, it would not sink into the depths, but would instead float upon the surface like a colossal golden ball. This is because Saturn is primarily composed of light gases like hydrogen and helium, which are loosely packed compared to the rock and metal of Earth. The planet is a puffed-up giant, taking up a tremendous amount of space while maintaining a surprisingly airy composition. This lightness defies our intuition about how heavy such a massive object should be, reminding us that size does not always equal density in the strange physics of the outer solar system. It exists as a buoyant wonder, a massive sphere of gas that rides the waves of gravity, suspended in the void with a lightness that belies its grandeur. A perfect hexagon shape crowns the north pole of Saturn, swirling in a perpetual and precise geometric storm. In nature, we are accustomed to seeing curves and circles, from the shape of bubbles to the spirals of galaxies. But Saturn presents us with a rare marvel of straight lines. This six-sided jet stream is immense, measuring about 20,000 miles, or roughly 30,000 kilometers, across, large enough to span about 2 Earths across. The winds within this geometric wonder rush at hundreds of miles per hour, yet the sharp angles of the hexagon remain stable, rotating with the planet's spin. Scientists have watched this feature for decades, and it changes color with the seasons, shifting from blue to gold as the long Saturnian years pass. It is a mystery of fluid dynamics that seems to follow its own hidden rules, creating a structured order amidst the chaotic winds. The storm spins silently at the top of the world, a mathematical perfection etched into the clouds, watching over the planet like a strange, enduring eye. Saturn's largest moon, Titan, is the only moon in the solar system known to possess a substantial and dense atmosphere. Most moons in our celestial neighborhood are airless, cratered worlds of silent rock exposed to the vacuum of space. But Titan is wrapped in a thick orange blanket. This atmosphere is so dense that the surface pressure is about 50% higher than what we experience here on Earth, meaning you could walk on its surface without a pressurized suit, though you would need protection from the cold. The air is rich in nitrogen, much like our own, but it is filled with a haze of organic molecules that hides the surface from view. For a long time, this moon remained a mystery, its features veiled by the opaque clouds that swirl around it. It is a world that feels strangely familiar, yet entirely alien, a place where the wind whispers through a sky that is not blue, but a deep golden smog. It stands as a lonely outpost, holding on to its air with a gravitational grip, protecting its secrets beneath a heavy, hazy sky. Saturn orbits the Sun at a tremendous average distance of about 886 million miles, or roughly 1.4 billion kilometers. This vast separation places the ring planet far out in the chilly depths of the solar system, well beyond the warmth of the inner rocky worlds. From this remote vantage point, the Sun appears not as a blazing orb that fills the sky, but as a particularly bright star, shining with only about 1% of the intensity it has on Earth. Because of this immense distance, light itself, traveling at incredible speeds, takes roughly 80 minutes to journey from the Sun to Saturn's cloud tops. The planet exists in a realm of perpetual twilight and deep cold, where temperatures hover far below freezing. It is a slow, lonely march through the dark, far removed from the hustle of the inner planets. Yet, even across this great divide, the Sun's gravity holds Saturn firm, tethering the giant in a wide, sweeping path that marks the boundary of the visible solar system for the ancient astronomers. While its journey around the Sun is slow and leisurely, Saturn spins on its axis with incredible speed, completing a day in just over 10 hours. This rapid rotation makes Saturn the second fastest spinning planet in our solar system, surpassed only by its giant neighbor, Jupiter. Imagine a world so massive, yet spinning so quickly, that the Sun rises and sets twice within the span of a single Earth day. This immense centrifugal force flings the planet's gaseous atmosphere outward, causing the clouds to race in bands parallel to the equator. The winds generated by this spin are ferocious, reaching speeds that would tear apart structures on Earth. Yet from a distance, they appear as serene stripes of cream and gold. The sheer velocity of the planet's rotation creates a dynamic environment where weather patterns are stretched and pulled across thousands of miles. It is a giant top spinning in the dark, maintaining its momentum from the very birth of the solar system, a restless sphere of gas that never sleeps, turning forever in the quiet vacuum of space. The small, icy moon Enceladus shoots plumes of water vapor far out into space, creating a misty trail that feeds one of Saturn's rings. This bright, white moon was once thought to be a frozen solid ball of ice, silent and inactive like so many others. However, we now know that beneath its frozen crust lies a global ocean of liquid water, kept warm by the tidal stretching of Saturn's gravity. Through cracks near the moon's south pole, known as tiger stripes, this subsurface water erupts in geysers that spray ice crystals and vapor miles high. These gentle eruptions contribute material to Saturn's E-ring, creating a ghostly halo that traces the moon's orbit. It is a profound realization that this tiny world is active and alive with geological processes, breathing its essence out into the void. Enceladus acts as a generous creator, sharing its hidden oceans with the space around it, painting a faint, watery circle around its parent planet in a continuous, silent offering of ice and mystery. The rings of Saturn are not a single solid sheet, but are separated by wide gaps, the most famous of which is the Cassini division. When you look at images of Saturn, you might notice a distinct dark band that seemingly cuts the bright rings in two. This gap is about 3,000 miles wide, or roughly 4,800 kilometers, a distance large enough to fit the entire planet of Mercury inside with room to spare. The division exists because of the gravitational pull of a moon called Mimas, which orbits further out, Mimas acts like a cosmic shepherd, tugging repeatedly on any ring particles that drift into this specific zone, eventually clearing them out and keeping the lane empty. It is a beautiful example of orbital resonance, where gravity sculpts the structure of the rings over millions of years. The gap is not truly empty, but holds far less material than the bright rings on either side, creating a stark contrast. It serves as a reminder that invisible forces are constantly at work, carving silence and space into the glittering grandeur of the ring system. Saturn is composed almost entirely of hydrogen and helium, the very same primordial elements that fuel the stars. Unlike Earth, which has a solid crust of rock and soil beneath our feet, Saturn has no true surface to stand upon. If you were to descend into its atmosphere, you would simply sink through thicker and thicker layers of gas, with the pressure building immensely around you. As you travel deeper, the hydrogen gas would eventually be compressed so tightly that it would behave like a liquid, and further down still, like a strange metal. The planet is essentially a ball of captured nebula, preserving the chemical recipe of the early solar system from billions of years ago. It sits on the threshold of being a star, though it lacks the sheer mass required to ignite nuclear fusion. Instead, it remains a gas giant, a massive reservoir of the universe's most abundant materials, held together by gravity in a colossal swirling sphere that dominates its corner of the sky with a soft golden glow. Saturn is the undisputed king of moons, with over 140 distinct natural satellites orbiting its massive form. The sheer number of moons creates a bustling, miniature solar system surrounding the ringed planet, each satellite following its own unique path. These moons range from the titanically large, like Titan itself, to tiny moonlets less than a mile across that are barely distinguishable from the ring particles. Some orbit close to the planet, skimming the edges of the rings, while others travel in wide, distant loops that take years to complete. This diverse family of worlds includes captured asteroids, icy spheres, and cratered rocks, all bound to Saturn by its immense gravitational reach. New moons are still being discovered as our technology improves, revealing more hidden companions in the dark. It paints a picture of a crowded, dynamic environment where the planet is never truly alone. Saturn acts as a gravitational anchor, holding this chaotic and beautiful swarm of satellites in a delicate, eternal dance around its golden equator. A single year on Saturn, the time it takes to complete one orbit around the Sun, lasts for about 29 Earth years. Because Saturn travels such a vast path in the outer solar system, its seasons are incredibly long and drawn out. If you were born on Saturn, you would not reach your first birthday until nearly 3 decades of time had passed on Earth. A single season, be it summer or winter, lasts for over 7 years, allowing the weather patterns to settle in for a long, enduring stay. This slow pace is a stark contrast to the frantic speed of the inner planets, giving Saturn a sense of stately, majestic patience. Generations of humans can live and pass away, while Saturn completes just a few leisurely circles around the Sun. It reminds us that time is relative to where we stand in the cosmos. The planet moves with the unhurried grace of a giant, marking the passage of epochs with a slow, silent rhythm that echoes the deep, timeless nature of the universe. Because it spins so rapidly on its axis, Saturn is visibly flattened at its poles and bulges significantly at its equator. This shape is known as an oblate spheroid, and Saturn is the flattest of all the planets in our solar system. The difference is dramatic. The planet is about 3,700 miles, or roughly 5,900 kilometers, wider at the equator than from pole to pole. This bulging is caused by the intense centrifugal force of its 10-hour day, which pushes the fluid and gas of the planet outward against the pull of gravity. Through a telescope, this squashed appearance is often one of the first things observers notice after the rings. It gives the planet a slightly oval silhouette, distinguishing it from the perfect spheres of the rocky worlds. This deformation is a physical memory of the planet's momentum, a frozen wave of gas held in balance. It shows us that even a planet as massive as Saturn is flexible and yielding, shaped by the simple, relentless physics of its own spin. On the surface of Titan, there are vast lakes and seas, but they are filled with liquid methane and ethane instead of water. Titan is the only place in the universe, other than Earth, where we have found stable liquid sitting on the surface. However, in the deep freeze of the outer solar system, water is as hard as granite, so the role of fluid is taken by hydrocarbons. These alien seas have familiar features like shorelines, bays, and islands, yet they exist at temperatures near -290 degrees Fahrenheit, or -179 degrees Celsius. Rain falls from the orange sky, flowing into rivers that carve channels into the icy ground, eventually pooling in these dark, mirror-like bodies of liquid. It is a hydrological cycle that mimics Earth's, but with completely different chemistry. The lakes are calm and still, reflecting the hazy sky above, undisturbed by the waves we might expect. They represent a strange, parallel version of our own world, a silent, frigid landscape where the liquids of life are replaced by the fuel of stars. Saturn possesses a powerful magnetic field that is nearly perfectly aligned with its rotation axis, unlike the tilted fields of other planets. This invisible shield extends far out into space, creating a protective bubble called a magnetosphere that deflects the solar wind. The field is generated deep inside the planet, likely by the churning of metallic hydrogen, a state of matter created by extreme pressure. What makes Saturn unique is that its magnetic north pole lines up almost exactly with its geographic north pole, a symmetry that is rare in the chaotic dynamics of planetary cores. This alignment has puzzled scientists, as usually, a tilt is needed to maintain the field strength. The magnetosphere is immense, stretching millions of miles toward the Sun and even further behind the planet in a long tail. It creates a vast, invisible structure that surrounds the moons and rings, humming with charged particles. It stands as a silent guardian, a force field of immense energy that wraps the planet in a safe, magnetic embrace as it travels through the dark. Although the main rings stretch out for roughly 175,000 miles, or 280,000 kilometers, they are incredibly, almost impossibly, thin. If you were to build a scale model of Saturn, where the rings were as wide as a city, the rings themselves would be thinner than a sheet of tissue paper. On average, the vertical thickness of the rings is only about 30 feet, or roughly 10 meters. This extreme ratio of width to thickness makes them the flattest structure known in the solar system. When Saturn reaches a point in its orbit where the rings are edge-on to Earth, they seem to vanish completely from view, becoming an invisible line. It is astounding that so much material can be distributed over such a vast area without piling up into a cloud. The particles collide and settle into this razor-thin plane, governed by the delicate balance of momentum and gravity. It is a structure of immense grandeur but fragile dimensions, a sweeping disk of ice that is both massive and ethereal, floating like a whisper around the planet. Just like Earth, Saturn experiences shimmering auroras that dance in glowing circles around its north and south poles. These celestial light shows are created when charged particles from the solar wind are trapped by Saturn's magnetic field and funneled toward the polar regions. When these particles slam into the gases of the upper atmosphere, they excite the atoms, causing them to glow. On Saturn, these auroras shine brightly in ultraviolet light, which is invisible to the human eye, but can be seen by spacecraft cameras. They can last for days, flickering and pulsing in sync with the solar wind and the rotation of the planet. Sometimes, the moons themselves leave footprints in the aurora, creating spots of light connected to their orbits. These curtains of energy are massive, towering hundreds of miles above the cloud tops. They represent a connection between the sun and the planet, a visual manifestation of the invisible forces that bind the solar system together, painting the polar skies with the silent, ghostly fire of the cosmos. The mysterious moon Iapetus has a bizarre two-toned appearance, with one hemisphere as white as snow and the other as dark as charcoal. This dramatic contrast makes Iapetus one of the most distinctive objects in Saturn's family, resembling a cosmic yin and yang symbol. The leading side of the moon, which faces forward as it orbits, is covered in a dark, reddish dust that absorbs sunlight and warms the surface. The trailing side remains icy and bright, reflecting the sun's rays. This duality is likely caused by the moon sweeping up dark particles from a distant ring, while ice migrates from the warm side to the cold side, deepening the divide over millions of years. It is a world where day and night are etched into the ground itself, a permanent shadow and a permanent frost. The moon orbits far from Saturn, tumbling through space with its two faces exposed to the stars. It serves as a canvas for the subtle processes of space weathering, a silent sphere that wears the history of its journey on its skin. Deep within the center of Saturn, the core temperature soars to nearly 21,000 degrees Fahrenheit, or about 11,700 degrees Celsius. While the cloud tops we see are freezing cold, the heart of the planet is intensely hot, radiating more energy into space than it receives from the sun. This internal heat is a remnant from the planet's formation billions of years ago, as well as the result of helium rain falling toward the core and generating friction. This inner fire drives the ferocious winds and storms that play out in the upper atmosphere, powering the weather from below rather than from above. It turns the planet into a dynamic engine, churning and mixing its gases over eons. The pressure at the center is millions of times greater than at Earth's surface, crushing matter into states we can barely simulate in labs. This hidden warmth is the lifeblood of the gas giant, a secret furnace burning slowly in the dark, keeping the planet active and alive despite the freezing vacuum that surrounds it. The tiny moon pan-orbits within the rings and has a distinct ridge around its equator, giving it the appearance of a cosmic ravioli. This peculiar little moon clears a gap in the rings known as the Encke gap, acting as a guardian for that empty lane. As it travels, it sweeps up ring particles that stray too close, and over time, this material has piled up around its middle to form a wide, flat ridge. Pan is only about 17 miles, or 28 kilometers across, yet its gravity is enough to affect the vast rings around it. The ridge makes the moon look like a flying saucer or a dumpling, a shape that is unique to the ring-shepherding moons. It shows how the environment shapes the object, as Pan is literally built from the dust it orbits through. It is a playful sculptor in the serious business of orbital mechanics, a small, oddly shaped rock that quietly maintains order in the grandeur of Saturn's rings, wearing a belt of the very ice it protects. When the astronomer Galileo Galilei first observed Saturn through his primitive telescope in 1610, he was baffled by its shape. His telescope was not powerful enough to resolve the rings clearly, so instead of a ringed planet, he saw a central sphere with two smaller objects on either side. He described Saturn as having ears or handles, and wondered if the planet was actually three bodies sitting in a row. Years later, when the rings tilted edge on and disappeared, he was even more confused, wondering if the planet had swallowed its children. It took decades of better optics and observation to understand that these appendages were actually a flat disk surrounding the planet. This historical confusion reminds us of how difficult it is to perceive the true nature of the cosmos from our distant vantage point. It was a slow unveiling of beauty, a puzzle that required patience and time to solve, transforming a confusing smudge of light into the magnificent, ringed wonder we know and admire today. The moon, Mimas, carries a massive impact crater that dominates its surface, making it look like a watchful eye staring out into the void. This crater, named Herschel, is immense relative to the moon's small size, spanning about 80 miles, or roughly 130 kilometers across. The impact that created it was nearly catastrophic. Had the colliding object been slightly larger, it might have shattered the little moon entirely. Instead, Mimas survived, bearing this colossal scar as a testament to the violent history of the early solar system. The walls of the crater rise steeply, and its central peak stands tall, casting long, sharp shadows across the crater floor. Despite this evidence of ancient destruction, the moon remains in a stable orbit, a silent survivor drifting through the calm of space. It serves as a reminder of resilience, a small icy world that withstood the chaos of the past to find its place in the peaceful, orderly procession of Saturn's satellites. Unlike the other spherical moons that rotate with predictable grace, the moon, Hyperion, tumbles chaotically through space. Most moons are tidally locked, keeping one face toward their parent planet, but Hyperion spins unpredictably, meaning its day length is constantly changing. Its shape is also peculiar. It looks like a giant, porous sponge, riddled with deep craters that have not been smoothed over by time. This sponge-like appearance is due to its low density, suggesting it is a loose collection of ice and rock with vast caverns inside. As it orbits in the chaotic zone near Titan, the gravitational tugs from the larger moon keep Hyperion off balance, preventing it from ever settling into a steady rhythm. It is a wild, untamed spirit in a system of order, tumbling freely in the dark. This erratic dance makes it unique, a wandering rock that refuses to conform, spinning through the eons with a freedom that defies the strict laws governing its neighbors. Deep within Saturn's atmosphere, the extreme pressure and heat may turn carbon into falling diamonds. In the upper layers, lightning storms turn methane gas into soot, which falls slowly toward the planet's interior. As this carbon descends, the crushing pressure increases, first hardening it into graphite, and then, deeper still, compressing it into pure diamond. These precious stones, perhaps as large as hail, would rain down through the liquid hydrogen ocean, eventually melting into a liquid sea of carbon near the superheated core. It is a dazzling thought that the sky of this giant world might weep diamonds, a wealth beyond measure, falling unseen in the dark. This process highlights the exotic and powerful chemistry of gas giants, where common elements are transformed into treasures by the sheer weight of the atmosphere. It paints a picture of a hidden, glittering storm, a secret rain of jewels that falls forever into the deep, hot heart of the planet. Ghostly markings known as spokes occasionally appear on Saturn's rings, defying the laws of gravity before fading away. These mysterious dark smudges stretch radially across the bright rings, looking like the spokes of a massive wheel. They are not permanent features, but transient shadows that form and dissolve over a matter of hours. Scientists believe these spokes are made of microscopic dust particles that are lifted away from the ring plane by electrostatic forces, suspended briefly by the planet's magnetic field. They tend to appear more frequently during the planet's equinox, when the sun hits the rings edge-on. It is a phenomenon where electricity and dust dance together, creating fleeting patterns on the grandest canvas in the solar system. These phantom shapes remind us that the rings are not just static rocks, but a dynamic, electrically charged environment. They appear like whispers in the ice, momentary glitches in the perfection of the rings that hint at the complex, invisible forces at play. Saturn emits a constant stream of radio waves that, if shifted into the range of human hearing, would sound like an eerie, shifting song. These radio emissions, known as Saturn kilometric radiation, are generated by the planet's intense auroras, where charged particles interact with the magnetic field. The Cassini spacecraft recorded these signals, revealing a complex soundscape of rising and falling tones that varies with the planet's rotation. This song is not carried by air, but by the electromagnetic spectrum, broadcasting the planet's presence across the cosmos. It is a melody of physics, a signal that pulses in time with the spin of the gas giant. While space is a vacuum, and therefore silent to our ears, instruments reveal that it is actually alive with the hum of energy. Saturn acts as a cosmic broadcaster, singing a lonely, complex tune into the void, a frequency of nature that tells the story of its magnetic power to anyone with the tools to listen. Roughly every 20 to 30 years, a colossal storm known as the Great White Spot erupts in Saturn's atmosphere, circling the entire planet. Unlike the constant storms on Jupiter, this phenomenon is periodic, arriving with the rhythm of Saturn's long seasons, usually when the northern hemisphere tilts toward the sun. The storm begins as a small, bright cloud, but quickly expands, churning up fresh ammonia ice from the deep layers and spreading a tail of white clouds that wraps around the globe. These storms are ferocious, generating lightning flashes thousands of times more powerful than anything on Earth. Yet from space, they appear as elegant bands of bright white interrupting the golden haze. It is a seasonal awakening, a release of built-up energy that refreshes the planet's face. The Great White Spot serves as a reminder of the planet's hidden power, a sleeping giant that wakes once a generation to paint the sky with the brilliance of a storm, before settling back into its calm, golden slumber. The moon Tethys is marked by a massive canyon system called Ithaca Chasma, which stretches nearly 3/4 of the way around its icy surface. This giant valley is roughly 60 miles, or about 100 kilometers, wide and runs for an incredible distance, scarring the face of the moon. It is believed that this canyon formed when Tethys was young, and its internal ocean froze solid. As water turns to ice, it expands, and the moon literally cracked open to accommodate the extra volume. Alternatively, the shock from a massive impact elsewhere on the moon might have shattered the crust. Today, it stands as a frozen monument to ancient geological stress, a rift that spans a world. The canyon is deep and silent, a vast trench where the sun casts long, dramatic shadows. It is a scar of growth, a sign that even frozen moons change and evolve, their history written in the deep fractures that break the smooth perfection of their ice. Far beyond the main bright rings lies the Phoebe ring, a colossal and nearly invisible halo of dust that dwarfs the rest of the system. This ring is tilted at an angle of 27 degrees to the main rings and starts about 3.7 million miles, or 6 million kilometers, away from the planet. It is so vast that if you could see it from Earth, it would appear as wide as 2 full moons in our sky. The ring is made of dust and debris blasted off the small, distant moon, Phoebe. Because the particles are so spread out and dark, this ring remained undiscovered until infrared telescopes spotted it in 2009. It is a secret companion to the planet, a tenuous veil of darkness that spins in the opposite direction to the other rings. It represents the immense scale of Saturn's influence, a subtle, shadowy border that marks the outer limits of the ring system, holding the memory of a tiny moon's dusty trail. The Cassini spacecraft spent 13 years orbiting Saturn, revolutionizing our understanding of the planet before becoming part of it forever. Launched in 1997, this robotic explorer traveled billions of miles to reach the ring giant, sending back hundreds of thousands of breathtaking images. It discovered new moons, revealed the secrets of the rings, and tasted the spray of Enceladus's geysers. In its final act, known as the grand finale, Cassini performed a series of daring dives between the planet and its rings, a region no spacecraft had ever touched. Finally, low on fuel, it was guided into Saturn's atmosphere to protect the pristine moons from contamination. As it descended, it sent back data until the very last second, eventually melting and becoming one with the planet it had studied for so long. It was a noble end to a journey of discovery, a machine made by humans that now rests as vapor within the golden clouds, forever a part of the world it revealed to us. The icy moon Rhea possesses a tenuous atmosphere of oxygen and carbon dioxide, a rare feature for a satellite. Though this atmosphere is incredibly thin, trillions of times less dense than Earth's, it was the first time a spacecraft directly detected oxygen molecules around a moon other than our own. This oxygen is not created by plants, but by high-energy particles from Saturn's magnetic field slamming into the moon's icy surface and breaking apart water molecules. Rhea is a heavily cratered, frozen world, looking much like a larger version of our own moon, but made of ice. The presence of this fragile envelope of gas adds a layer of complexity to its silent, frozen landscape. It suggests that chemistry happens even in the coldest corners of space, where radiation works upon the ice to release the breath of life-giving elements. Rhea stands as a quiet laboratory, holding a ghost of an atmosphere close to its chest, a whisper of oxygen in the vacuum. Two of Saturn's small moons, Janus and Epimetheus, perform a unique gravitational dance where they swap orbits every 4 years. These moons orbit at almost the exact same distance from the planet, with one trailing slightly behind the other. Instead of colliding, the inner moon catches up to the outer moon, and their gravitational interaction causes them to trade places. The inner moon gains speed and moves up, while the outer moon slows down and drops lower. They never pass each other, but rather execute a graceful U-turn relative to one another, maintaining a safe distance. This orbital choreography is the only known example of its kind in the solar system. It is a delicate balance of forces, a cosmic waltz that has continued for billions of years without error. The moons move in harmony, sharing their path around the giant planet, demonstrating that gravity can create patterns of cooperation and rhythm, just as easily as it creates collisions. The rings of Saturn cast enormous, dramatic shadows onto the planet, and the planet in turn casts a long shadow across the rings. This interplay of light and dark changes with the seasons, acting as a giant celestial sundial. During the solstice, when the rings are tipped toward the sun, their shadow on the planet is short. But during the equinox, the sun hits the rings edge-on, and the shadow becomes a thin black line. Conversely, the planet's shadow stretches out across the vast expanse of the rings, plunging the ice particles into darkness for hours at a time. This shadow play reveals the three-dimensional nature of the system, adding depth and texture to the view. It creates a constantly shifting landscape of day and night within the rings themselves. It is a visual reminder of the geometry of space, where the simple obstruction of sunlight creates vast regions of cold and dark, painting the passage of time in shades of grey across the golden world. Saturn's signature golden yellow hue comes from high-altitude clouds of ammonia crystals that veil the planet. Unlike the blue of Earth or the rusty red of Mars, Saturn is wrapped in a thick haze that mutes the colours of the storms below. Sunlight reflects off this upper deck of ammonia ice, giving the planet its calm, butterscotch appearance. Beneath this top layer, there are likely clouds of ammonium hydrosulfide and water, which would be darker and more colourful, but they are hidden from our view. The ammonia haze acts as a global blanket, softening the features of the giant and giving it a uniform, serene complexion. It creates a world that looks soft to the touch, a massive sphere of pastel tones floating in the blackness. This colour is the result of chemistry and cold, a specific mixture of gases freezing at the top of the atmosphere to create a permanent, golden twilight that defines the face of the planet for all who observe it. The rings of Saturn exist inside a boundary known as the Roche limit, a distance where the planet's gravity is too strong for a moon to form. Within this invisible line, the tidal forces pulling on an object are stronger than the gravity holding that object together. If a moon were to drift too close, inside this limit, it would be torn apart by the planet's pull, crumbling into rubble. The rings are essentially a moon that never was, or a moon that was destroyed, kept in pieces by the sheer power of Saturn's mass. They are suspended in a zone of destruction, yet the result is a structure of immense beauty. It is a delicate balance where the debris is trapped in orbit, unable to coalesce but unwilling to leave. The Roche limit acts as a cosmic grinder, ensuring that the material remains spread out in a shimmering disk, a permanent display of the tension between gravity and cohesion. In 1979, the Pioneer 11 spacecraft became the first human-made object to fly past Saturn, blazing a trail for future explorers. It was a perilous journey, as no one knew exactly how thick the rings were or if the spacecraft would survive passing through the ring plane. Pioneer 11 threaded the needle, passing just 13,000 miles or 21,000 kilometers below the clouds, and discovered 2 new moons and a new ring in the process. Its grainy images were the first close-ups humanity had ever seen, revealing the banding of the atmosphere and the details of the rings that had been blurs in telescopes. This brave little probe acted as a scout, venturing into the unknown to prove the path was safe. It opened the door to the outer solar system, a mechanical pioneer that sailed the cosmic ocean to bring us the first intimate greeting from the ring giant. The moons Telesto and Calypso are known as Trojan moons because they share their orbit with a much larger moon, Tethys. In a rare gravitational arrangement, Telesto sits 60 degrees ahead of Tethys, and Calypso sits 60 degrees behind, locked in stable points known as Lagrange points. These two small moons are protected by the gravity of Tethys and Saturn, held in place as if by invisible tethers. They travel through space in a fixed formation, never crashing into their larger companion and never drifting away. This configuration is named after the asteroids that share Jupiter's orbit, but it is beautifully played out here in miniature. It shows that orbits can be shared peacefully, with smaller worlds tucking themselves into the gravitational pockets of larger ones. They are silent escorts, loyal companions that have flanked Tethys for eons, moving in a lockstep that demonstrates the precise and elegant mathematics of the heavens. The F-ring of Saturn is a thin, chaotic stream of ice that is shepherded by two tiny moons, Prometheus and Pandora. These moons orbit on either side of the narrow ring, one inside and one outside, and their gravity keeps the ring particles confined to a tight lane. Prometheus, the inner moon, occasionally dips into the ring material, creating knots and kinks in the stream, while Pandora, the outer moon, pushes stray particles back in. This constant gravitational tug-of-war creates a ring that looks braided or twisted, unlike the smooth lanes of the main rings. It is a dynamic, active boundary where the moons act like sheepdogs, herding the flock of ice. The interaction is a constant struggle for order, resulting in a complex, ever-changing structure. It is a beautiful example of nature's ability to create stability through opposition, with two small guardians maintaining a fragile line of ice in the vastness of space. Embedded within the Keeler gap of the A-ring is a tiny moon named Daphnis, also known as the Wave Maker. As this small moon, only about 5 miles or 8 kilometers wide, orbits Saturn, its gravity disturbs the edges of the ring gap. This creates vertical waves in the ring particles that rise as high as a mile, or 1.5 kilometers, above the flat plane. Daphnis sails through the gap like a boat moving through water, leaving a wake of ripples on both sides. These waves travel along with the moon, creating a visible texture in the otherwise smooth ring. It is a poetic interaction where a tiny rock sculpts the landscape around it, proving that even the smallest object can have a profound effect on its environment. Daphnis is an artist of gravity, tracing its path in 3-dimensional waves of ice, permanently surfing the edge of the rings in a silent, majestic display of fluid dynamics. While we cannot see it, the core of Saturn is believed to be a dense ball of rock and ice, roughly 10 to 20 times the mass of Earth. This solid heart is buried under tens of thousands of miles of gas and metallic hydrogen, subjected to pressures that are unimaginable. Unlike the distinct surface of a rocky planet, Saturn's core likely has no sharp boundary, but rather dissolves into the metallic fluid above it, creating a fuzzy mix of rock and gas. This core acted as the seed for the planet's formation, its gravity attracting the massive envelope of gas that we see today. It is the hidden anchor of the giant, a solid foundation lost in the deep, crushing dark. It reminds us that beneath the clouds and the grandeur, there is a physical heart to the planet, a heavy, silent center that holds the entire glorious system together against the centrifugal pull of its spin. Saturn is tilted on its axis at an angle of about 27 degrees, which is very similar to Earth's tilt of 23 degrees. This tilt means that Saturn experiences distinct seasons, just as we do, though on a much grander timescale. As the planet orbits the Sun, the northern and southern hemispheres take turns leaning toward the warmth. This changes the angle of the sunlight hitting the rings, causing their appearance to shift dramatically over the years. At times, The rings cast wide shadows over the hemisphere tilted away from the sun, cooling the winter side even further. This axial tilt is the heartbeat of the planet's climate, driving the slow rhythmic changes in weather and temperature. It connects Saturn to the familiar cycle of nature we know on Earth, a shared cosmic geometry that brings the passage of spring, summer, autumn, and winter to even the most distant and alien of worlds. It was the Dutch astronomer Christian Huygens who finally unlocked the secret of Saturn's shape, 45 years after Galileo first saw it. Using a telescope far superior to those of his predecessors, Huygens observed the planet in 1655 and realized that the confusing ears were actually a detached, flat ring. He proposed that Saturn was surrounded by a thin disk that nowhere touched the planet, a revolutionary idea at the time that transformed Saturn from a triple-bodied anomaly into a world of elegant geometry. This discovery also led him to spot the moon Titan, adding another layer to the planet's majesty. His clarity of vision allowed humanity to see the rings for what they truly were, a separate, suspended halo of light. It is a testament to the power of patience and better tools, as the blurry mystery resolved into a sharp, definable feature. Huygens gave the solar system its crown jewel, correcting our vision and allowing us to perceive the true, silent grandeur of the ring giant. Across the equator of Titan stretch vast fields of dunes that look remarkably like the deserts of Earth. Yet they are made of something entirely alien. These dunes are not composed of silica sand, but of dark, hydrocarbon grains, essentially tiny bits of plastic that have settled from the thick orange atmosphere. Rising as high as 330 feet, or about 100 meters, these dark waves of material stretch for hundreds of miles, shaped by the gentle, steady winds of the moon. They wrap around obstacles and flow across the landscape, mimicking the patterns of the Sahara or the Namib deserts. It is a striking example of convergent evolution in geology, where the same physical laws create similar shapes out of vastly different materials. These silent, dark dunes stand as a monument to the slow, persistent work of the wind, sculpting a landscape that is at once familiar and deeply strange. A plastic desert under a frozen orange sky. The winds of Saturn are among the fastest in the solar system, reaching speeds that are almost incomprehensible to us on Earth. Near the equator, the wind screams through the upper atmosphere at roughly 1,100 miles per hour, or nearly 1,800 kilometers per hour. This is 4 times faster than the strongest hurricane winds ever recorded on our planet. Unlike Earth, where mountains and continents break up the flow of air, Saturn is a smooth ball of gas, allowing the winds to build up tremendous momentum without resistance. They flow in distinct alternating bands, with easterly and westerly jets sliding past each other at incredible velocities. This creates a planet wrapped in speed, a world where the air itself is a projectile. It is a display of fluid dynamics on a massive scale, where the energy of the planet's spin and internal heat creates a perpetual high-speed storm that races forever around the golden globe. The sheer volume of Saturn is difficult to grasp, as it is a world that could swallow hundreds of hours. You could fit approximately 760 Earths inside Saturn, filling it like gumballs in a massive jar. Its diameter is about 9 times that of Earth, stretching roughly 72,000 miles or 116,000 kilometers across its equator. Despite this immense size, the planet spins so fast that its day is short and its density is low. This creates a paradox of a world that is huge but not heavy, a giant that dominates the sky with its presence but lacks the rocky substance of the inner planets. It stands as a bloated, majestic sphere of gas, a testament to the abundance of material in the outer solar system. It reminds us of how small our home truly is, a tiny rock that would be lost instantly in the vast, swirling caverns of Saturn's golden clouds. The moon, Dione, features a mysterious landscape known as wispy terrain, which appears as bright, delicate streaks against its darker hemisphere. For years, astronomers thought these wisps were deposits of frost from cryovolcanoes, painting the surface with snow. However, closer inspection by the Cassini spacecraft revealed that they are actually gigantic ice cliffs, some rising nearly 1,000 feet or 300 meters high. These cliffs are the result of ancient tectonic fractures, where the moon's crust cracked and pulled apart, exposing the brilliant, fresh ice beneath the weathered surface. From a distance, they look like soft brushstrokes, but up close, they are jagged, sheer walls of frozen water. This revelation changed our understanding of Dione from a passive world to one that was once geologically active. It is a scarred beauty, wearing the history of its internal stress as bright, white scars that shine eternally in the weak sunlight of the outer solar system. A phenomenon known as ring rain is slowly draining the magnificent rings of Saturn, pulling their material down into the planet. Charged particles of water ice from the rings interact with Saturn's magnetic field and are guided down magnetic field lines into the upper atmosphere. This process dumps an Olympic-sized swimming pool's worth of water products onto the planet every half hour. It is a silent erosion, a cosmic weathering that suggests the rings are not eternal, but a temporary adornment. Over hundreds of millions of years, this rain, combined with material falling into the equator, will eventually cause the rings to fade and vanish. It adds a poignant element of time to the system, reminding us that we are lucky to live in the era where Saturn is at its most beautiful. The planet is slowly consuming its own halo, drinking the ice of the rings in a long, slow sip that spans the eons. The small moon Atlas boasts a unique and peculiar shape that resembles a classic flying saucer or a spinning top. It has a spherical center, but it is surrounded by a massive, smooth, equatorial ridge that creates a wide brim. This ridge was likely formed as the moon swept up dust and particles from the rings, which piled up around its middle due to the low gravity. Atlas orbits just outside the A-ring, acting as a shepherd, and its shape is a direct result of its environment. It is a world built by accumulation, a literal product of the rings it guards. The smoothness of the ridge contrasts with the rougher texture of the core, giving it an artificial, constructed appearance. It floats through space as a geometric curiosity, a silent sentinel that has grown a wide belt of ice to match the flat, expansive aesthetic of the ring system it calls home. Deep inside Saturn, the conditions are right for a strange weather phenomenon, where helium separates from hydrogen and falls like rain. In the immense pressure of the interior, the helium condenses into droplets that sink through the lighter liquid hydrogen, journeying toward the core. As these droplets fall, they release gravitational potential energy, which is converted into heat. This process is essentially the planet differentiating itself, sorting its elements by weight, and it explains why Saturn is so much warmer than it should be for its age. It is a hidden rain that has been falling for billions of years, a slow-motion shower of liquid metal deep within the dark, crushing depths. This internal mechanism acts as a heater for the planet, keeping the winds churning and the storms alive. It is a reminder that the most powerful weather often happens where we cannot see it, in the secret liquid heart of the giant. In 1980, the Voyager 1 spacecraft swept past Saturn, peeling back the veil of mystery that had surrounded the planet for centuries. It provided the first high-resolution images of the complex ring structure, revealing that what looked like a few broad bands were actually thousands of tiny ringlets. Voyager 1 also shifted our focus to Titan, diverting from its path to get a closer look at the Moon, confirming it had a thick atmosphere. This detour meant Voyager 1 could not visit Pluto, but the data it gathered on Titan was worth the sacrifice. It showed us a world with organic chemistry, a tantalizing hint of life's building blocks. The flyby was a fleeting but transformative moment, a brief encounter that rewrote the textbooks. It stands as a pivotal chapter in exploration, where a robotic ambassador from Earth first saw the true, intricate face of the Lord of the Rings. The C ring is the faint, inner cousin to the spectacular A and B rings, often overlooked because of its transparency. Located closest to the planet, this ring is much wider than the famous Cassini division, yet it contains far less material. It is composed of darker, dirtier ice than the bright outer rings, making it difficult to see without a powerful telescope. Looking through the C ring is like looking through a sheer black veil. You can easily see the body of Saturn through it. Its particles are sparse, creating a ghostly, ethereal band that lacks the brilliance of its neighbors. It serves as a gentle introduction to the ring system, a fade-in from the emptiness of space to the density of the main rings. It is a region of shadow and subtlety, a quiet, dark lane where the ice particles are few and far between, spinning in a lonely, silent orbit. In the future, a rotorcraft lander named Dragonfly will soar through the skies of Titan, marking the first time we will fly a vehicle on another moon. Set to arrive in the 2030s, this drone-like explorer will take advantage of Titan's low gravity and thick atmosphere to hop from location to location. It will study the chemistry of the dunes and the impact craters, searching for signs of prebiotic life. This mission represents a leap in our exploration, moving from orbiters and rovers to an atmospheric flyer. It evokes a sense of wonder, imagining a machine buzzing like a large insect over the alien orange landscape. Dragonfly will be our eyes and ears in this strange world, visiting places we can only dream of. It is a promise of future discovery, a bold step into the hydrocarbon fog to unlock the secrets of a world that is eerily similar, yet totally distinct from our own. Beneath the icy crust of Titan, scientists believe there lies a global ocean of liquid water, potentially as salty as the Dead Sea on Earth. While the surface is covered in liquid methane and ethane, the deep interior harbors this hidden reservoir, kept liquid by the heat of tidal friction and radioactive decay. This subsurface ocean makes Titan an ocean world, similar to Europa and Enceladus, despite its vastly different surface conditions. It separates the outer icy shell from the rocky core, allowing the crust to drift and shift over time. This hidden layer adds a profound depth to the Moon, suggesting that even under the most alien of surfaces, the familiar substance of water persists. It is a secret kept in the dark, a potential abode for chemistry and life that remains protected by miles of ice, waiting silently in the deep. For all their visual splendor and vast width, the rings of Saturn contain a surprisingly small amount of mass. If you were to gather all the ice and rock from the rings and compress them into a single object, it would likely be smaller than the Moon Mimas. This realization is staggering. The rings are essentially a veneer, a broad but incredibly thin display of debris. They are a light, structure in a gravitational sense, a puff of cosmic glitter rather than a heavy, solid disk. This low mass suggests they might be relatively young in cosmic terms, perhaps only a few 100 million years old. It highlights the efficiency of nature, creating a structure of maximum visual impact with a minimum of material. The rings are a majestic illusion of solidity, a grand gesture made of dust and ice that weighs almost nothing compared to the giant planet it adorns. Orbiting between Mimas and Enceladus are three tiny egg-shaped moons named Methane, Anthe, and Pallene. These small worlds, known as the Alkyonides, are so small that they were only discovered by the Cassini spacecraft. They are smooth and covered in ice, likely coated by the spray from Enceladus's geysers. They act as calm, silent companions in the busy space near the rings, undisturbed by the chaos of collisions. Their surfaces are remarkably smooth, lacking the heavy cratering of their neighbors, which suggests they are covered in a loose accumulation of soft particles. They are the quiet siblings of the Saturnian family, drifting unobtrusively in the shadow of the larger moons. These tiny, floating eggs remind us that the solar system is full of minor wonders, small and perfect in their own way, filling the gaps between the giants with their silent, steady presence. From the vantage point of Saturn, the Sun appears 10 times smaller in the sky than it does from Earth. It shines not as a blazing, heat-giving disk, but as an intensely bright point of light, piercing the gloom of the outer solar system. The daylight on Saturn is dim, comparable to a very cloudy day on Earth, or the twilight just after sunset. This weak illumination means that the planet and its moons exist in a permanent state of dusk, where shadows are soft and long. The warmth we associate with the Sun is almost non-existent here, replaced by the deep, biting cold of space. It is a somber, majestic lighting, casting the golden clouds and the silver rings in a cool, detached glow. It reminds us of the isolation of Saturn, a world that orbits in the dim borderlands of the Sun's influence, far from the fire of the inner system. At Saturn's south pole, there is a massive hurricane-like storm that actually possesses a warm eye, a feature unique in the solar system. While the eye of a hurricane on Earth is calm, the eye of this Saturnian storm is warmer than the surrounding air, creating a deep, distinct hole in the clouds. This vortex is roughly 2/3 the diameter of Earth, a swirling pit of gas that looks like a dark pupil staring into space. The walls of the storm rise high above the central eye, creating a stadium-like effect. It is a thermodynamic oddity, where the sinking gas heats up, clearing the clouds and revealing the depths below. This warm spot stands as a lonely beacon of heat at the bottom of the world, a silent, swirling cylinder of energy that anchors the chaotic weather of the southern hemisphere. Running exactly along the equator of the two-toned moon Iapetus is a massive, towering ridge that gives the moon the appearance of a giant walnut. This mountain range is roughly 800 miles, or 1,300 kilometers, long and rises as high as 12 miles, or 20 kilometers, dwarfing Mount Everest. The origin of this ridge is one of the solar system's greatest mysteries. It might be the remnant of a collapsed ring, or the result of the moon spinning much faster in its youth and bulging at the middle. It makes the moon look like two halves joined together, a constructed artificial shape in a natural universe. The ridge is steep and rugged, casting enormous shadows across the icy plains. It is a physical timeline of the moon's history, a frozen belt of rock that defines the moon's silhouette and adds to its reputation as the strangest object in Saturn's orbit. The influence of Saturn extends into our daily lives through the calendar, as the day Saturday is named directly after the planet. In ancient Roman astrology, Saturn was the god of agriculture, wealth, and time, and the seventh day was dedicated to him. This linguistic connection has survived for thousands of years, preserving the reverence the ancients held for the slow-moving star. Unlike other days in English which are named after Norse gods, Saturday retains its Roman root, linking us back to the astronomers who first charted the planet's path. It is a subtle, weekly reminder of the planet's presence in human culture. Every time we reach the end of the week, we are unknowingly paying tribute to the ring giant. It symbolizes a time of rest and the passage of time itself, fitting for a planet that moves with such slow, majestic deliberation across the sky. The number of individual particles that make up Saturn's rings is effectively infinite, a figure so large it defies human comprehension. There are billions upon billions of icy fragments, each one a tiny moon in its own right, following its own orbital path around the planet. They range from grains of sand to house-sized boulders, all jostling and bumping into one another in a chaotic yet organized flow. Despite their vast numbers, they move together as a fluid, creating the illusion of solid sheets and bands. If you could count them, it would take lifetimes, as the sheer density of the B ring alone packs them tightly together. They are the dust of the cosmos, gathered and sorted by gravity into a masterpiece of numbers. It is a swarm of silence, a collective entity made of countless lonely shards of ice, dancing together in the dark. On Saturn, the change of seasons is accompanied by a significant temperature lag due to the planet's immense thermal inertia. Just as the hottest part of the day on Earth is afternoon rather than noon, Saturn's atmosphere takes a long time to warm up or cool down after the sunlight changes. This means that the peak of summer or the depth of winter occurs years after the solstice has passed. The massive amount of gas acts as a heat bank, storing and releasing energy slowly, smoothing out the transitions between the seasons. This lag adds a sense of lethargy to the planet's climate, a resistance to change that fits its giant stature. It suggests a world that operates on a timescale of deep, slow breaths, where the reaction to the sun is measured not in days, but in years, a patient, enduring response to the cycle of the stars. Hidden within the A-ring are thousands of tiny moonlets that create disturbances known as propellers in the surrounding ice. These small objects, roughly the size of a football stadium, are not large enough to clear a full gap in the rings, but they are massive enough to flick the nearby ice particles into new positions. The result is a two-lobed structure that looks remarkably like the propeller of an old airplane, spinning in the midst of the ring plane. Scientists have nicknamed these features after famous aviators, such as Earhart and Blériot, honoring the pioneers of flight. These propellers reveal the hidden population of the rings, showing us that the system is not just dust and giant moons, but a continuous spectrum of sizes. They act as miniature engines of chaos, churning the smooth lanes of ice into localized wakes. It is a tribute to human history etched into the frozen disk, where the memory of flight circles forever in the silent vacuum of space. Thermal imaging of the moon Mimas reveals a bizarre heat signature that looks exactly like the character Pac-Man from 1980s video games. While the moon appears as a simple cratered sphere in visible light, the heat map shows a distinct V-shape of warmer regions that creates a mouth ready to gobble up a smaller dot. This strange pattern is caused by the way the texture of the surface varies across the moon. The icy walls of the giant Herschel crater retain heat differently than the rest of the terrain. The contrast between the cold, dense ice and the powdery snow creates this sharp thermal boundary. It is a whimsical coincidence of geology and physics, a hidden image that can only be seen with eyes that detect heat. It serves as a playful reminder that the universe is full of surprises, painting familiar shapes on distant worlds through the complex interaction of sunlight, shadow, and ice. During the rare event of the Saturnian equinox, the rings reveal that they are not as perfectly flat as they appear, but are actually filled with towering structures. When the sun shines directly on the edge of the rings, shadows stretch out across the disk, revealing vertical clumps of ice that rise as high as 2.5 miles or 4 kilometers. These mountains in the rings are caused by the gravitational passage of moons, which splash the ring particles upward out of the plane. For most of Saturn's long year, the high sun angle hides these features, making the rings look like a smooth sheet. But for a brief window every 15 years, the low light exposes the rugged, three-dimensional texture of the system. It transforms our view from a flat disk into a jagged landscape of frozen peaks. It is a fleeting revelation of height in a world of width, a secret range of mountains that rises and falls in the silence of the rings. Determining the exact length of a day on Saturn was a challenge that puzzled scientists for decades, because the planet has no solid surface landmarks to track. On Earth or Mars, we can watch a crater or a continent spin around to measure the day, but Saturn is a swirling ball of clouds where everything moves at different speeds. Astronomers tried to use the rotation of the magnetic field as a clock, listening for the rhythmic radio pulses it emits. However, the Cassini spacecraft discovered that the magnetic field does not wobble like other planets, making it incredibly difficult to pin down the true rotation rate of the core. It turns out the seasons actually alter the rotation of the magnetic signals, adding to the confusion. The planet guards its most basic statistic with layers of fluid complexity. It suggests a world where time is fluid and hard to grasp, a giant that spins to its own hidden internal rhythm, untethered from the simple mechanics of rock and stone. The icy moon Enceladus is the most reflective object in the entire solar system, bouncing back almost 100% of the sunlight that hits it. This extraordinary brightness is due to the constant fresh coating of snow provided by its south polar geysers. As water vapor erupts from the interior, it falls back onto the surface as pristine white frost, covering any dust or craters that might darken the moon. Because it absorbs so little sunlight, the surface temperature is incredibly cold, hovering around -330 degrees Fahrenheit or -201 degrees Celsius. To an observer floating nearby, Enceladus would be painfully bright to look at, a dazzling sphere of pure white against the black velvet of space. It is a self-cleaning world, constantly renewing its face with the spray of its own ocean. It shines like a polished jewel, a beacon of purity and ice that reflects the distant sun with a brilliance unmatched by any other moon or planet. Theoretical models suggest that early in the solar system's history, Saturn and Jupiter engaged in a dramatic migration known as the Grand Tack. In this cosmic dance, the two gas giants moved inward toward the Sun before gravitational interactions caused them to reverse course and migrate outward to their current positions. This massive movement of heavy planets acted like a snowplow, clearing out debris and shaping the arrangement of the asteroid belt and the smaller planets. Saturn's gravity played a crucial role in stabilizing the system, acting as a counterweight to Jupiter's influence. Without this ancient journey, our solar system might look very different, and Earth might not exist in its current habitable form. It paints a picture of a dynamic, restless youth for the planets, where giant worlds wandered through the dark. Saturn stands now as a settled traveler, its current orbit the final resting place of a voyage that sculpted the very architecture of our home system. Far beyond the orderly orbits of the main moons, Saturn is surrounded by a vast swarm of irregular moons that orbit at wild angles and extreme distances. These small, dark worlds are grouped into families named after Norse, Inuit, and Gallic mythology, reflecting their chaotic nature. Unlike the inner moons that formed with Saturn, these irregulars were likely passing asteroids or comets that were captured by the planet's gravity billions of years ago. Some orbit in retrograde, moving in the opposite direction of the planet's spin, while others follow highly elliptical paths that take them millions of miles away. They are the adopted children of the Saturnian system, drifters that were caught in the giant's net. They remind us that Saturn is not just a ruler of its own creation, but a collector of lost objects, gathering a diverse cloud of distant companions that patrol the lonely outer frontiers of its domain. The innermost of the rings, known as the D-ring, is a faint and dusty band that actually reaches down to touch the planet's atmosphere. This ring is so tenuous that it is almost invisible, yet it represents the bridge between the ring system and the planet itself. It is located just 4,100 miles, or 6,600 kilometers, above the cloud tops, a proximity that is perilous for the orbiting particles. Here, the material spirals slowly inward, eventually burning up as ring rain in the Saturnian sky. The D-ring is not a static feature, but a flowing river of dust, a conveyor belt that delivers the ring's oldest material into the planet's embrace. It is a region of intimate connection, where the boundary between the celestial halo and the giant world blurs. It shows us that the rings are not forever separate, but are slowly, gently becoming part of the planet they adorn. On the surface of the moon Tethys, mysterious reddish arcs appear as if someone has spray-painted graffiti across the white ice. These strange, narrow lines are not geological features like cracks or valleys, but seem to be chemical stains on the surface. They were discovered late in the Cassini mission and have puzzled scientists as they do not match any known craters or mountains. The leading theory is that charged particles from Saturn's magnetosphere, or perhaps plasma from other moons, are bombarding the ice and chemically altering it to create the red color. The arcs are hundreds of miles long, yet only a few miles wide, precise strokes of color on a blank canvas. They serve as a reminder that these moons are exposed to the invisible environment of space, where radiation acts as a paintbrush. Tethys wears these red stripes as a silent badge of its journey, a mysterious signature written by the energy of the planet it orbits. The moon Phoebe is a celestial rebel, orbiting Saturn in a direction opposite to almost every other moon and the planet's own spin. This retrograde orbit strongly suggests that Phoebe is not a native of the Saturn system, but an intruder from the deep outer solar system, likely a Centaur or a Kuiper belt object. It was captured by Saturn's gravity long ago and forced into a lonely, distant path. Phoebe is dark, battered, and dense, composed of materials that are different from the icy inner moons. Because it moves against the traffic of the other debris, any collisions it has are violent and high speed, kicking up the massive dust ring that trails behind it. It represents the chaotic past of the system, a visitor that stayed. Phoebe orbits in solitary defiance, a dark, ancient rock that marches to its own beat in the far reaches of the giant's influence. The atmosphere of Titan is so thick and rich in chemistry that it is thought to resemble the atmosphere of early Earth before life began. Nitrogen makes up about 95% of the air, with methane and hydrogen filling out the rest, creating a prebiotic soup that is frozen in time. Unlike Earth, Titan lacks the oxygen that supports us, but it is rich in the complex organic molecules called tholins that rain down from the sky like orange soot. This similarity makes Titan a time capsule, allowing scientists to study the kind of chemical reactions that might have jump-started life on our own planet billions of years ago. It is a world suspended in a state of potential, a laboratory of creation that is too cold to wake up. It offers a glimpse into our own deep past, a mirrored reflection of Earth's infancy, held in the deep freeze of the outer solar system. Saturn possesses a feature known as the string of pearls, a regular chain of clearing in the clouds that reveals the deep internal glow of the planet. Observed primarily in infrared light, this phenomenon occurs at roughly 33 degrees north latitude, where a massive atmospheric wave creates breaks in the upper cloud deck. Through these gaps, the heat from Saturn's interior escapes, appearing as bright, glowing beads against the darker, cooler clouds. There can be dozens of these pearls lined up around the planet, each one a window into the hot, hidden depths. They are actually cyclonic storms, spaced out with mathematical precision by the planetary waves. It is a beautiful example of how fluid dynamics can create order from chaos, stringing storms together like a necklace. These glowing spots remind us that beneath the calm, golden haze, the planet is radiant with its own internal light, wearing a chain of storms like royal jewelry. The Cassini division, the large, dark gap in the rings, is not actually empty space, but is filled with a faint, dusty material similar to the sea ring. While it looks like a void from a distance, a traveler passing through it would still encounter sparse ice particles and dust. The gap appears dark only in contrast to the incredibly bright and dense A and B rings that flank it. The reason it is clearer than its neighbors is due to the rhythmic gravitational tug of the moon Mimas, which destabilizes the orbit of any large object that tries to settle there. It acts as a no parking zone enforced by gravity. However, the finest dust can drift through, creating a ghostly, translucent bridge between the bright rings. It is a reminder that emptiness in space is often an illusion, and even the darkest gaps are filled with the subtle, drifting whispers of matter. The moon Aegaeon is one of the smallest known moons of Saturn, a tiny, elongated rock less than half a mile, or about 1 kilometer across. It resides within the bright arc of the G-ring, a faint and partial ring outside the main system. Aegaeon is likely a source of the dust for this ring, shedding material as it is bombarded by micrometeoroids. It is so small that it is barely a world, more of a large piece of debris that has been given a name. Its orbit is trapped in a resonance with the massive moon Mimas, which dictates its path and keeps it safe within the ring arc. It is a lonely speck of matter, a tiny seed hidden inside a faint ribbon of dust. Aegaeon represents the smallest scale of the Saturnian family, a humble rock that plays its part in maintaining the delicate structure of the G-ring, floating quietly in the vastness. One of the most profound aspects of Saturn is the sheer distance between the individual ring particles in the outer regions. While the B ring is dense and packed, in the fainter rings like the C ring or the Cassini division, The ice chunks can be separated by miles of empty space. If you were standing on a boulder in these regions, your nearest neighbor might be a distant speck of light, far away in the darkness. It is a lonely, silent existence for these frozen sentinels, drifting in solitary orbits around the giant. The sense of scale here is immense. The rings look solid from Earth only because of our distance. Up close, they dissolve into a vast, sparse field of debris. It is a calm, open emptiness, where each piece of ice travels its own path, accompanied only by the silence and the distant, golden glow of the planet. Saturn's moon Titan creates a wind of charged particles that affects the planet's magnetic field. As Titan orbits, it moves through Saturn's magnetosphere. But because Titan has no magnetic field of its own, its thick atmosphere interacts directly with the plasma. This interaction strips away about 7 tons of material from Titan's atmosphere every day, creating a trail of ions behind the moon. This neutral wind of lost atmosphere expands the magnetosphere of Saturn, adding mass to the magnetic bubble. It is a form of cosmic breathing, where the moon exhales its substance into the space around the planet. The relationship is symbiotic and complex, connecting the moon to the planet by invisible lines of force and matter. It paints Titan not just as a rock in orbit, but as an active participant in the electromagnetic and phytomagnetic environment of the Saturnian system, leaving a chemical wake in the dark. The density of the A-ring is not uniform, but contains waves of density called spiral density waves, similar to the arms of a galaxy. These waves are created by the gravitational pull of moons orbiting outside the rings, which tug on the ring particles in a rhythmic pattern. As the particles bunch up, they create spiral patterns that wind tightly around the planet, moving through the ring like a traffic jam moves through cars. To an observer, they would look like ripples in a pond, spiraling outward from the center. These waves are the visible footprints of gravity, showing us exactly where the moons are exerting their influence. They add a texture of motion to the rings, proving that the disk is not a static picture, but a fluid, moving medium. It is a beautiful display of physics, where the invisible force of gravity is translated into elegant, spiraling lines of ice. Saturn emits twice as much heat as it receives from the Sun, making it a glowing source of energy in the infrared spectrum. This internal heat source is a mystery that simple cooling cannot explain. The planet should have cooled down billions of years ago. The leading theory is that helium rain is releasing gravitational energy, but there may be other mechanisms at work deep in the core. This heat drives the ferocious weather, the jet streams, and the storms, powering the planet from the inside out. It means that Saturn is not just a passive reflector of sunlight, but an active, living engine. It burns with a slow, simmering fire of compression and friction. In the cold dark of the outer solar system, Saturn acts as a localized star, a warm hearth that keeps its atmosphere churning and its moons bathed in invisible radiation. If you were to float in the upper atmosphere of Saturn at night, the sky would never be truly dark due to the brilliance of ring shine. The rings reflect a massive amount of sunlight, acting like a giant arching moon that spans the entire sky. In the planet's summer hemisphere, the rings would illuminate the cloud tops with a soft silver light, casting shadows and revealing the textures of the storms below. This ring shine is far brighter than the full moon on Earth, creating a perpetual dreamlike twilight even on the night side of the planet. The colossal arch of ice would dominate the view, glowing with a spectral light that cuts through the darkness. It creates a world without a true night, a place where the sky is always adorned by the glittering, reflected glory of the halo that surrounds it. On the moon Titan, rain falls in slow motion, creating a mesmerizing spectacle that would look like a special effect to human eyes. Because Titan has low gravity, similar to our own moon, and a very thick atmosphere that provides air resistance, the raindrops fall much slower than they do on Earth. A drop of liquid methane, which can be twice the size of a terrestrial raindrop, drifts down at a leisurely pace, taking its time to reach the surface. Imagine a storm where the rain descends like snowflakes or feathers, a gentle, silent curtain of orange liquid settling onto the dunes and lakes. This slow-motion weather creates a dreamlike quality to the landscape, where the violence of a storm is replaced by a heavy, drifting calm. It is a world where gravity and air conspire to alter the rhythm of nature, turning a downpour into a soft, hypnotic dance of fluids in the dark. The small moon Prometheus acts as a cosmic thief, stealing material from the F-ring as it orbits. As Prometheus swings close to the ring in its elliptical path, its gravity pulls a streamer of icy particles away from the main band. These streamers look like dark, gossamer threads, connecting the moon to the ring, creating a visible link between the two. Over time, Prometheus dips in and out, creating a repeating pattern of these stolen channels that ripples through the ring. It is a parasitic relationship where the moon feeds on the ring, yet paradoxically helps shape and define it. This interaction reveals the fluid nature of the rings, showing that they are not solid barriers but flowing rivers of ice that can be bent, pulled, and consumed by the gravity of passing worlds, knitting the moon and ring together in a complex gravitational bond. The famous hexagonal storm at Saturn's North Pole changes color with the seasons, shifting its hue over the span of years. When the Cassini spacecraft first arrived during the northern winter, the hexagon was a deep, bluish color, hidden in the polar shadow. However, as spring arrived and sunlight began to illuminate the pole, the storm slowly transformed into a rich, golden color. This change is believed to be caused by photochemical haze being produced as sunlight reacts with the atmosphere. The more sunlight the pole receives, the more golden haze is generated. It is a planetary mood ring, a massive atmospheric feature that blushes in response to the slow arrival of the sun. This shift takes years to complete, a gradual, silent transformation that marks the passage of time on a world where a single season lasts for 7 Earth years. While the rings of Saturn look translucent in many images, the B ring is so dense that it would block almost all sunlight if you were floating beneath it. This central ring contains the highest concentration of ice particles, packed so tightly that they cast a pitch-black shadow on the planet's surface. If you were to look through the B ring at a distant star, the star's light would be completely extinguished by the wall of tumbling ice. In contrast to the ghostly C ring or the A ring, the B ring is a formidable barrier, a true solid-looking disk in the sky. It contains the bulk of the ring system's mass, a heavy, opaque river of frozen water that dominates the view. It serves as the spine of the ring system, a region of intense collisions and density where the sheer amount of material creates a profound and heavy darkness. The moon, Helene, is a Trojan moon of Dione, meaning it orbits in the same path as the larger moon, but stays safely ahead of it. Helene is often described as having a melted Epier-Malta appearance, with smooth, flowing features that look like wax that has softened in the heat. This strange, softened terrain is likely due to the accumulation of dust and debris that Helene sweeps up as it travels in Dione's orbit. It has no large craters, suggesting that its surface is loose and constantly shifting, filling in any scars. It moves through space like a silent ghost, a smooth, pale rock that has been sculpted by the gentle rain of cosmic dust. Helene is a scavenger of the system, a world that grows by gathering the leftovers of the orbital path, wearing a coat of fine powder that softens its edges against the harsh backdrop of space. The subsurface ocean of Enceladus is not just salty water, but is likely carbonated, similar to soda water. The plumes that erupt from the moon contain carbon dioxide, which suggests that the ocean below is fizzy and bubbling. If you could dip a cup into the waters of Enceladus, it might fizz and bubble like a mineral spring on Earth. This carbonation helps drive the eruptions as the gas expands and pushes the water up through the cracks in the icy shell. It paints a picture of a chemical ocean that is dynamic and chemically active, not a stagnant pool. This soda ocean holds the potential for complex chemistry, mixing elements in a pressurized, warm environment deep beneath the ice. It is a hidden, effervescent world where the dark waters bubble in silence, waiting to be sprayed out into the void to freeze into crystal snow. From the distance of Saturn, Earth appears as nothing more than a tiny, pale blue dot close to the Sun. Because Saturn is so far away, Earth remains very close to the Sun in the sky, often lost in the glare of the star. Seeing our home from the ringed planet requires looking toward the twilight, spotting a small, fragile speck of light that shines with a steady blue hue. This perspective shrinks all of human history, all our oceans and continents, into a single pixel of light floating in the vastness. It is a humbling vantage point that emphasizes the isolation of the outer planets. To a traveler at Saturn, Earth is just another star in the sky, a distant memory of warmth and rock left far behind in the journey toward the cold, golden giants of the outer solar system. Saturn's southern hemisphere is home to a region dubbed Storm Alley, where storms appear with high frequency and intensity. Located at roughly 35 degrees south latitude, this band of the atmosphere is a breeding ground for electrical storms that can last for months. The lightning from these storms is millions of times more powerful than lightning on Earth, generating radio signals that crackle across the solar system. These storms appear as bright, turbulent white clouds, bubbling up from the deep, disrupting the smooth golden haze. They are powered by the planet's internal heat, churning the atmosphere in a chaotic, never-ending cycle. Storm Alley is a restless zone, a place where the planet's energy vents itself in flashes of light and violence. It serves as a reminder that beneath the serene appearance of Saturn lies a volatile, churning engine of weather that never truly rests. The particles in Saturn's rings orbit at different speeds depending on their distance from the planet, creating a complex shear flow. According to Kepler's laws, the particles closer to Saturn must travel faster to counteract the stronger gravity, while those further out travel more slowly. This means that a particle in the inner C ring is racing ahead of a particle in the outer A ring, and even within the rings, adjacent lanes are sliding past each other. This difference in speed creates a constant friction and collision between particles, grinding them down and preventing them from clumping together into moons. It is a flowing, fluid disk, not a solid wheel. If you could watch it from above, you would see the inner tracks overtaking the outer ones in a mesmerizing spiral of motion. It is a grand celestial racetrack where the lanes are made of ice, moving in a perpetual silent synchronization governed by gravity. Between the C ring and the B ring lies the Maxwell Gap, a dark lane that contains a dense, non-circular ringlet. This ringlet is an anomaly because it is not a perfect circle. It is an ellipse that precesses, or slowly rotates, around the planet. The Maxwell ringlet behaves like a wave, pulsating in and out as it orbits, defying the circular perfection of its neighbors. It is likely maintained by a resonance with one of the moons, though the exact mechanic is complex. The gap itself is relatively wide, creating a clear boundary between the faint inner rings and the massive, bright B ring. It serves as a transition zone, a dark moat that separates the ghostly dust of the interior from the heavy, icy grandeur of the main system. It highlights the diversity of the rings, where smooth circles, chaotic gaps, and elliptical waves coexist in a single, flat plane. The G ring is a faint, narrow ring that lies outside the main system, appearing more like a ghost than a solid structure. It was difficult to detect for a long time because it is composed of very fine dust rather than large icy boulders. This ring is maintained by the tiny moon Aegeon, which is trapped within it. Unlike the sharp, defined edges of the A and B rings, the G ring is diffuse and fuzzy, looking like a smoke ring blown into the dark. It represents a different kind of ring architecture, one dominated by dust and shadows. It is a subtle feature, a whisper of material that floats in the gap between the main rings and the E ring. The G ring is a reminder of the unseen complexity of Saturn, a delicate arc of dust that requires the perfect lighting to reveal its faint, ethereal presence. The surface of Titan is surprisingly young in geological terms, with very few impact craters compared to other moons. While moons like Rhea and Tethys are pockmarked with billions of years of cosmic scars, Titan's surface is relatively smooth. This indicates that the moon is geologically active, with processes like wind, rain, and perhaps cryovolcanism constantly resurfacing the world and erasing old craters. The dunes shift, the rivers flow, and the lava of water and ammonia covers the evidence of past impacts. It is a world that heals itself, wiping away the history of violence to present a fresh face to the universe. This youthfulness makes Titan feel alive and dynamic, a place where the landscape is still being written today. It stands in contrast to the dead, frozen worlds around it, a moon that breathes and changes under its thick orange blanket. The texture of the individual ring particles is not like hard rock or solid ice cubes, but more like fluffy snowballs or clumps of frost. They are porous and fragile, made of water ice that has aggregated loosely in the vacuum of space. If you were to touch one, it might crumble in your hand like a soft snowball. This fluffy nature helps explain how the rings react to collisions. Instead of shattering like glass, the particles buffer and absorb the energy, merging and breaking apart gently. It creates a system that is dissipative, dampening the violence of the orbital dance. These soft, white clumps of ancient snow float together in the billions, creating the illusion of a solid disk. It is a gentle realization that the grandest structure in the solar system is built from the most delicate of materials, a majestic river of frost drifting in the void. Every 20 years, Jupiter and Saturn align in the sky in an event known as a Great Conjunction, a meeting of the two giants. From Earth, they appear to merge into a single bright star, a celestial event that has been watched by humans for millennia. This alignment is not just visual. The gravitational interaction between the two largest planets in the solar system has shaped the history of our neighborhood. Their rhythmic meetings tug on the asteroids and other planets, maintaining the stability of the solar system over billions of years. It is a meeting of kings, a scheduled rendezvous in the slow clockwork of the cosmos. For a brief moment, the golden light of Saturn and the white light of Jupiter combine, a rare and powerful union that marks the passage of generations. It reminds us that Saturn is part of a greater family, locked in a timeless dance with its giant brother. The tiny moon Anthe orbits between Mimas and Enceladus and is accompanied by a faint, partial ring arc. Unlike a full ring that circles the planet, this arc is incomplete, covering only a portion of the orbit. Anthe is the source of this dust, shedding material as it is struck by micrometeoroids. The arc is held in place by the gravity of Mimas, which prevents the dust from spreading out into a full circle. It creates a smile of dust in the sky, a broken line of debris that trails the little moon. This partial ring highlights the delicate gravitational balancing act that occurs in the Saturnian system. It is a fleeting, fragile structure, a temporary trail of crumbs left by a small, wandering moon. It shows us that rings come in many shapes, from the majestic full disks to the shy, broken arcs of the minor moons. Saturn's magnetic tail, the extension of its magnetosphere pushed by the solar wind, stretches outward for hundreds of millions of miles. This invisible structure is so vast that it can reach all the way to the orbit of Titan and beyond, creating a magnetic wake behind the planet. When Saturn's orbit takes it into the magnetosphere of Jupiter, or when the solar wind changes, this tail flutters and shifts like a windsock in a breeze. It is a dynamic, unseen appendage of the planet, a comet-like tail of magnetism that interacts with the vacuum of space. Inside this tail, plasma and charged particles flow, guided by the field lines. It paints the planet as a moving vessel in the sea of solar particles, leaving a wake of energy that ripples through the darkness long after the planet has passed. For the ancient astronomers, Saturn represented the outer boundary of the known universe, the final frontier before the sphere of the fixed stars. It was the slowest moving of the wandering stars, taking nearly 30 years to complete its circuit, earning it associations with time, old age, and limits. They called it the Keeper of the Keys, or the Grim Reaper, symbols of the end and the boundary. For thousands of years, humanity believed that nothing existed beyond Saturn's orbit. It stood as the sentinel at the edge of reality, the gatekeeper of the infinite. While we now know of Uranus, Neptune, and Pluto, Saturn retains that majestic aura of being the last of the classical planets. It is the limit of the naked eye, the furthest world we can see without aid, marking the edge of our natural vision and the beginning of the deep, invisible dark. The temperature of Saturn's rings is incredibly cold, hovering around -300 degrees Fahrenheit or -180 degrees Celsius. In the shadow of the planet, the temperature drops even further, plunging the ice into a deep thermal shock. However, when the sun hits the rings, they warm up slightly, and this constant cycle of heating and cooling can cause thermal stress in the ice particles. The rings are essentially a vast field of frozen debris that has never known warmth. They exist in a state of permanent preservation, locked in the deep freeze of the outer solar system. This extreme cold is what allows the ice to remain stable for so long, preventing it from sublimating away into gas. It is a landscape of absolute frigidity, a glittering expanse of frost that endures in the silence of the vacuum, untouched by the heat of the inner stars. The moon Phoebe is scarred by a massive impact crater named Jason, which covers a significant portion of its surface. This crater is a record of a violent collision that nearly destroyed the moon eons ago. Phoebe's dark, battered surface suggests it has been a target for comets and asteroids for billions of years, acting as a shield in the outer solar system. The crater walls are steep and expose bright ice beneath the layer of dark, carbon-rich dust that coats the moon. It creates a stark contrast, a bright wound on a dark world. This crater tells the story of survival in a chaotic environment. Phoebe is a veteran of the solar system, a hardened survivor that bears the marks of its history, orbiting in a lonely retrograde path that keeps it far from the safety of the inner moons. Saturn stands as a silent, majestic witness to the history of our solar system, a jewel that has fascinated every generation of humans who have looked up. From the first ancient shepherds who tracked its slow movement, to the modern scientists who sent robotic envoys to touch its clouds, it has remained a source of wonder. Its rings are a lucky add to the accident of time, a temporary masterpiece of ice and light that we are privileged to see in our brief existence. The planet spins on, indifferent to our gaze, a golden giant surrounded by its retinue of silent moons. It is a place of storms and diamonds, of frozen oceans and orange skies, of chaos and perfect order. As we finish our journey, we leave Saturn to its eternal silent dance, a beautiful ringed memory drifting slowly through the velvet dark of the cosmos. And so, our journey through the majestic and silent world of Saturn comes to a gentle close. We have drifted past the shimmering rings, witnessing the eternal dance of ice and dust that has circled the giant for aeons. We have seen the silent storms that churn deep within the golden atmosphere, settling into the rhythm of a day that spins with a grace we can barely imagine. From the icy geysers of Enceladus to the thick orange mists of Titan, we have touched the edges of a system that is both vast and strangely peaceful. It is a kingdom of gravity and light, where the chaos of the early solar system has settled into a perfect, silent clockwork. The giant planet hangs in the void, a beacon of stability that watches over its many moons with a patience that outlasts the stars themselves. As we pull away, the intricate details of the rings blend back into a single, glowing halo, and the moons become mere points of light once more. Saturn remains behind, a silent guardian of the outer dark, turning slowly in the velvet expanse of space. It reminds us that there is beauty in the cold and order in the vast emptiness. The storms may rage, but from our distance, there is only stillness and grace. We leave it now to its eternal slumber, a golden jewel set against the endless black, spinning on and on in the quiet comfort of the universe, undisturbed by time. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of Saturn and the gentle music carry you softly into rest. Sleep well. Good night.